Hopefully it's not Mark Hamill just over and over again. Come on, man. Give some money. Okay, so what's that one say? Which problem is it again?
54 and 11.1.
54, 11, 1. And what's it say? What's mine say? Sweet.
I don't remember exactly. Well, I know that it gives you like a series or a sequence, I guess.
Oh, okay. Let me look it up. Figure it out of the book. 54?
Yes.
Oh, yeah. So this is sort of like somebody else was asking me something like this. So here's the series. Sequence. That series on the brain.
Yeah.
Yeah. Okay. Right?
Yeah.
Okay. And this question is determine whether this converges or diverges.
It's easy to see that, but it's like.
Yeah, how do you show it?
Yeah.
Like, how do you show it? Do you guys see how this is like two sequences in one? Do you guys see this sequence here? Isn't that a straightforward sequence?
Yeah.
So there's one sequence, let's call it, so let's say this is AN, and it's made up of BN and CN. So there's the sequence AN, yes? It's made up of BN, and BN is 1, 1/2, 1/3, 1/4. And CN is every other one, 1/3, 1/4, 1/5, so forth, right? Man, you're dying already. Poor little dude. Can you guys see that? There's two sequences, two very clear sequences living in that one sequence. Maybe? All the other problems give you AN explicitly, right? Like one of them is arctangent of n over n and something else, right? This one just gives you elements. So if you could just write it in with a function of n form, I could attack it to see if it converges or diverges. I could just attack it with a limit. Okay. So what does this look like as a, well, in English would be great, instead of hieroglyphics? I don't know what that was. What's this look like? What is what's the nth term look like?
1 over n.
Yeah, 1 over n. Because when n is 1, I get 1 over 1. When n is 2, I get 1 over 2. Okay, that's one sequence that lives in there. What does this sequence look like?
1 over 2 plus n?
Yeah. When n is 1, let's get 3 on the bottom. When n is 2, I get 4 on the bottom. And the one on top's always 1. Both of those sequences go to what?
0.
0. So then the whole sequence converges.
And that essentially, that's how I prove it? I
Yes.
write them separately?
So there are sequences that exist that kind of have two sequences in them. There are sequences such that the odd elements follow this rule. This is basically what this is, right? And the even elements follow this rule. So the odd elements, the first, the third, the fifth, they follow this rule. And the even elements follow this rule.
Okay, so it's just a sequence of two separate rules?
Yes, and the only way that the whole sequence has one limit, the only way that it converges, is if each subsequence, is that okay for me to say? Subsequence? If each subsequence has the same limit, then the whole sequence has that limit. It's sort of like the old idea of a limit having to go to the same place.
So when I'm proving that, I'm separating them, taking the limit of Bn and Cn, and saying
Showing that they have the same limit.
they both converge
Yeah.
at 0, so
Yeah.
therefore it's
I like
convergent at 0.
Yes.
So with like kind of like you said, can we force it to like be two subsequences?
You don't have to force it, it just is.
Yeah, okay.
So real quick, if I had this sequence, a new problem, if I had this sequence, 1, 1 over 2, 2, 1 over 3, 3, 1 over 4, 4, 1 over, I think I got off track, damn it. Blah, 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 right?
Yeah.
Do both subsequences converge?
No. Well,
Do you guys see the subsequences? One of them is 1, 2, 3, 4,
Yeah.
and the other one is 1/2, 1/3, 1/4. Well, I have 2 1/3. Dead, gummit. I did get off track. Well, yeah, I think you guys see what I was trying to go for, right?
Yeah.
Right? So this subsequence goes to 0, but this subsequence goes to infinity. So that doesn't, so this sequence diverges. Maybe? Yes?
What's the difference between sequences and series?
Okay, I love it. A sequence is just a series of elements. A series is what you get when you add up all of those elements. Let me say it again. A sequence is just a collection of elements, right? Does this converge? Yes, because I can see they're getting smaller. But if I add every single element up, does that converge? That's a harder question now. So a sequence is just a definition that generates numbers, right? So there's a collection of numbers. A series is when I add all of these up. I don't know how many times I can say that. That's really it. That's it. So a sequence is just the elements. So the elements themselves can converge, but when I add them all up, they might diverge. And maybe. Yes?
Kind of like peripheral math question. Could you relate that to like set theories? If like a set of numbers, and then can you do like a series like mathematics on that?
Sure. Yeah. But that's not exactly what we're going to do, but yeah, that would be like a higher level math class where you start talking about, I don't even know if you, how do you mean? I'm not even sure if you know what you're getting into.
Like a set of all real numbers or something like that?
Sure.
Yeah.
Okay.
No, I don't know a lot about it. I just saw like a cool video on that. I was just-
Oh, okay. Yeah, set theory, we're not going to get fully into set theory, hell no. But some of what we're talking about definitely relates to set theory, for sure. In fact, a little bit of everything we talk about relates to set theory. Yeah.
Is that Calc 3?
No, that's
Linear algebra?
that's much higher. Yeah. Yes.
To elaborate on what the last gentleman was asking, similar question about annotation on a problem like this. If we wanted to describe this as two sequences in the same given set, could we use that notation, something like a sub n equals 1 over n for all n,
Yes.
where n is a member of 2k plus 1.
Yes. So,
And it's equal to 1 over 2 plus n for all n, where n is a member of 2k,
all right, so
something like
I'm
that.
kind of happy you did this. I think I was sort of staying away from this, but remember piecewise functions?
Yeah.
Okay. So you would say that a sub n equals 1 over n for n, what is it? Odd. And it equals 1 over 2 plus n for n even. Piecewise sequence. Ooh, I like it. Did you have to rally this? No. Could you? All day long. Maybe? Yes?
And so if I were to prove that it converges, I'd have to prove that both
Each-
of those
yes.
converge and then they equal each other.
Yes.
Okay.
Yeah. Yes. Yes. So, because eventually the overall sequence has to agree on where it's going. So it wouldn't be enough if one of them goes to 0 and the other one goes to 1, because now you got that.
Yeah.
It's sort of like sine or cosine. It can't agree on what it's doing. Yes.
So does that mean it's divergent necessarily or no?
In the case I just said, yes, it would be divergent because it doesn't converge to a single number.
Okay.
So sine n, does it go to infinity? Nope, but it also doesn't converge because it never agrees on what it's getting close to. It never gets closer to anything because it's, and maybe.
So what kind of is there like a name for that kind of divergence?
Yes, who was I talking to earlier? Oscillatory.
That
makes sense,
that
right?
would still be oscillatory, even though one goes to infinity and one just bounces.
Wait a minute. Was one of the examples we just did infinity? I can't remember. I don't think so.
So one of the examples we just did was 1, 2,
0
3,
and
4.
1 was one of them. So that's oscillatory because it's oscillating between 0 and 1. Sine n is not just oscillating between -1 and 1, it's oscillating between everything within there.
But one of the examples we just did was like 1 over 1.
Oh.
It's like
the one
1.
I had up here earlier?
Yeah.
Okay. So that wouldn't be oscillatory. Yeah.
Yeah, okay.
That's just purely that one's really strange because part of it goes to infinity while the other part of it goes to 0.
Yeah.
But it's not oscillatory really in the true sense of the word.
Yeah.
Okay. I love you guys. Really funky ass questions. I love it. Right. Our terminology is not quite robust enough to take care of every situation, but that is sort of oscillatory, but okay. Anything else from homework? Yes.
Functions which kind of like start off with these huge oscillations and then taper off and get smaller and smaller, that's also oscillatory?
No.
That converges at the end, right? So,
Yes.
Yeah.
So as long as it, so, all right, is this convergent?
Yeah.
Hell yeah, right? Why?
Approaching 0.
And again, to make it really true, I should put little dots, but you with me? Okay. You guys sort of with me? So that's obviously convergent because they agree that they're getting closer to 0. Everything's getting closer to 0. So how is this any different? Isn't it also agreeing to get closer to 0? It just happens to be doing it from both sides, right? I like it. Maybe. So this would be something like 1 over n sine n, or e to the negative n sine n, or cosine, whatever your favorite thing is.
So that would be an example of a series that's not monotonic, but is convergent?
Yeah, again, we're going to run into, okay, this is beautiful. We're going to run into a lot of theorems that say if, then. If it rains today, then I will bring my umbrella. Does that make logical sense? If it's raining, I'll bring my umbrella. Does it make sense the other way? If I bring my umbrella, then it will rain. Does that make sense? No. So if-then statements only work in the direction they're given. They don't necessarily work the other way. If a sequence is monotonic and bounded, what must it do? Converges. If a sequence converges, does it have to be monotonic or bounded? No. Okay. Maybe?
Doesn't it have to be bounded?
Yeah, it does have to be bounded. You know, you get what I'm saying. The if-then doesn't work.
I just got it.
I got excited. Okay. Maybe. Maybe. Okay. Okay. That, the thing I just said, I can't stress this enough. You might even want to make this into a note. We have got, and I'm going to, every time we hit a theorem, I'm going to try to remind you guys, the if-then only goes one direction for sure. Sometimes it might go both ways, but we'll say it if it's going to go both ways. Okay, maybe. Okay. Anything else from homework stuff? Any other questions? Hopefully you guys are getting into chapter 11 stuff. I did put it up on WebAssign. Yes, I did.
Yeah.
Okay, thank God. Okay. Let me see. Did I leave anything out? I think we got all the way through section 11. I mean, it's relatively easy, but that doesn't mean that there are some strange problems. So, for example, can anyone tell me anything about this beast here? Does anyone remember what that looks like? What arctangent looks like? Not like that. What? Sorry? Tangent, what does tangent look like?
It's asymptotic.
Where are the asymptotes for tangents?
Pi halves.
Yeah. And
It just goes-
technically, it looks like this, and it has infinite repeats of that, right?
Yeah.
Oh, I was thinking.
But if you remember, that would mean it wouldn't pass the horizontal line test, correct? So then it wouldn't have an inverse. But don't we have something we call inverse tangent, arctangent?
That's where you
So we have to restrict the domain. So if I take this and I flip it over the y equals x line, I end up with this, and the asymptotes are still at negative pi over 2, pi over 2. So what's the limit as n goes infinity of arctangent? Pi over 2. That might be a really useful thing to know. For example, right? Jeff, that doesn't work that way. So you're gonna have some L'Hopital stuff. You're gonna have some. You're gonna have some trig stuff. There's gonna be little things that you might have to kind of refresh on, but the basic idea is pretty simple. If the limit as n goes infinity is finite, the sequence converges. How could it diverge? Either the limit is infinite, or it doesn't agree on something, oscillatory, right? Maybe. Okay, so what's the difference then, real quick? I said this just a minute ago, but I really want to make sure you guys see the difference. What's the difference between this? No, you drew it right, Jeff. That'd be great. Right. Whoa, wow. And this. Let's see. Aren't they both oscillating forever?
Mm-hmm.
But only one of them is oscillatory divergent. Oscillatorily, let's just make up an adverb. Divergent, right? Which one converges? Obviously this one, right? Because it does eventually agree, hey, I'm gonna forever get closer to 0. Is this ever agree on some number that it will ever get closer to?
No.
No. Maybe. Is that all right? So don't just go, oh, it oscillates, so it's going to be divergent. That's not ever anything I said. There is a way to diverge that's called oscillatory divergence. Just because you're always oscillating doesn't mean you don't converge, right? When you pluck a guitar string, does it ever stop moving?
Yeah.
Thank the gods they do. Can you
Yes.
imagine if every guitar string ever plucked was still going? Keep it all just, right? Thank God it's dampened harmonics, right? So this is basically a plucked guitar string, and the frequency, the amplitude is minimizing every time. So thank God for friction and all that kind of stuff. Maybe? So this will converge to 0, thankfully, make that thing stop, right? Whereas this would be where we all go insane. Don't ever pluck another freaking guitar. Okay. All right.
Try the quiz.
Strange example, but I love that example. Okay. Anything else from that? You guys have got to get in this and try it out. You have no idea how it's going to be until you give it a try. Don't forget your shit from pre-calc. My God. Some of this shit should be quick. If I ask you, does this converge? Oh, God. You're dead. You're dead. All right. God, it's a constant battle. Okay. Does this converge?
Yes.
Why?
Because the highest power on the top and the bottom.
Yeah,
is
remember good old horizontal asymptotes? The question about sequence converging is about letting n get really big. What do all the elements do? All the elements seem to be approaching something. That's the question, right? So don't forget your pre-calc shit. This shouldn't be, to answer this, degree the same degree, top and bottom. Limit is
1/6.
1/6. Convergent. Right? Don't do L'Hopitals. You could. Right. But then you and I both go insane waiting for you to get there. Right? So stand on the shoulders of stuff you've done before, correct? You still have to kind of give me some idea. Don't just say convergent. You said I didn't have to do work. You gotta give me something, right? Is that okay? You guys remember that? Horizontal asymptotes?
What if
Look
it's
at the
like,
degrees.
it's like really obvious?
Huh?
What if it's like really obvious?
Like what? Give me an example.
Like the homework, the entire homework. Well, okay. So one of the questions of the homework was n to the 4th over n to the 3rd minus 2n. It diverges. I said diverges. I didn't
Why?
do anything else because the top power is greater than the bottom power. Just sort of
So
going.
then say that.
That's so much writing.
Gotta write it down.
I should-
I said you never read
I
it.
was hoping you were wrong.
When am I ever read? I'm just kidding.
Okay. It's true though.
Alright, how we doing? Is that alright? Yes?
I know you already kind of explained this during the hours, but could you re-go over why it's like with something at 4 over in the end over something that's not a polynomial? How
Oh,
do
yeah,
you do
yeah,
it?
Give it to me again, sorry.
Sorry. So like when it's like numerical base to the nth power.
Numerical base.
Yeah, so like 4 to the nth power.
I'll do 5 because I don't know.
Yeah, and then over like something 1 plus 2 to the nth power. So it's like obvious you can see the limit, but I'm saying like how would you do method 1 on that? Like, how do you know to do method 1?
Oh, so this is kind of neat. This is where we can expand on what we learned in pre-calculus. So watch this, kids. What's the only number I can't divide by? Zero. So if I divide by the biggest piece of this, 5 to the n, right? And that's allowed because n is going to infinity. That's nowhere near 0, right? So I can divide by that stuff. What do I get? I'll do the top. Okay. What do I get on the bottom? 1 over 5 to the n, right? Plus
2 to the n over 5.
That's right. 2 fifths to the n, right? 2 to the n over 5 to the n. What does this do as n goes to infinity? It
Zero.
goes to 0. What does this do?
It goes to 0.
Goes to 0. R is less than 1. Geometric. Geometric.
Wait, that's an R?
Well, that's
Yeah.
like it's
What's
yeah.
the form of geometric? R to the n, right?
Oh, yeah, yeah.
When does it converge?
when r is less than 1.
R is less than 1. Right? Compared to 0, but yeah. And actually it converges for negative, but don't. We'll get there. So this goes to 0. Right? So that's 1 over 0, so this goes to 0. It's divergent. Yeah, it diverges. It goes to
Undefined.
infinity. It diverges the old-fashioned way. It just goes to
So
infinity.
for that one, is the limit undefined? Or
The limit is undefined, but that doesn't answer the question.
yes.
The question is, does this converge or diverge? So since the limit's undefined, this diverges. Not undefined, but does not exist.
Yeah. Yeah.
In this case, you identify the biggest piece. Is it always going to be the numerator or?
No,
Okay.
no. So what if it would have been that? What would I still divide by?
2 over the n.
No, the biggest thing, 5 to the n. Got a 5. So now it'll be 2 over 5 to the n, right? Over 1 over 5 to the n plus 5 to the n divided by 5 to the n is. So this goes to 0, right? 1 over big, it's small. This goes to 0.
How does that go to 0? Oh, because it. Wait. Oh, because the.
What's 2 fifths times 2 fifths?
Because the number on the bottom gets bigger faster than the number on the top.
Yeah,
Okay.
yeah. So as long as r is less than 1, r to the n will go to 0.
Okay, I got
Right?
you.
Because imagine, isn't 2 fifths 0.4? Try to do 0.4 to the 10th in your calculator, right? It's going to be crazy small.
Yeah.
So now imagine 0.4 to the trillionth, to
So
the
this
trillionth,
one's
to the trillionth, to the
conversion.
trillionth, to the trillionth, to the trillionth. It's nowhere near infinity yet, but still. Okay. So that converges because the limit is 0. Does the limit have to be 0 for the sequence to converge?
No.
No, it just has to be some finite, agreed upon number, right? Maybe. So what is going to become crazy important? And that's why I like the question that happened earlier. What the hell is the difference between a sequence and a series? Sequences are always much easier to work with. I just care about what are the numbers doing, right? For sequences, I just care about what are the numbers doing. That's why I can just do a direct limit and be done with it. Series are when I take elements of a sequence and add them all together. You with me? And that's why one of the first things I talked about was, if I add an infinite number of numbers together, can it ever come out to be a finite number? And we saw, yes, it can. I don't know if you guys remember that. Okay, maybe. Anyway, so as we get into series, when I ask you, is this series convergent or divergent, it will always be a more involved problem than the sequence would be. The sequence just has to go to a number. Now let me ask you this. All right. What about the one we just had? Let me make a smaller one. What if I had and equals 3n squared plus 2 over 4n squared plus 2n minus 1.
What is this?
That's the sequence.
3 over 4 converges at 3 over 4.
So if I ask you, does this converge, you can be even more specific. What is the limit? 3/4, is that cool?
Yeah.
Equal degrees, ratio of the coefficients, 3/4. What does that mean?
Means the value gets infinitely closer to 3/4.
Yes, as I make this list. Well, let's see if we can do this real quick. If n is 1, that's 5 over 5. Oh my god, that's neat. Yes? Hopefully I do that right. If n is 2, oh shit, do I want to do
9.
14 over, or it's 2, so it's 14 over, right? 14 over 16, 20, 19. If n is 3, whatever. But eventually this is going to become so close to 3/4 forever, right? Now think about this. If I add every element in that sequence, and I mean every element, how many elements are there? Infinite numbers. If I add them up, can that ever be a finite answer? Because what am I doing eventually, basically? I'm adding 3/4 to itself forever.
So no.
It'd be infinite.
Yeah, so think about it. What must be true about a sequence so that the series, meaning if I add all the elements up, what must be true about the sequence so that the addition of all of them will be finite?
The limit has to be 0.
Limit has to be 0. Right, let me write that down. I'm doing this a little out of order, but I don't care.
Wait, are we in series now?
We are. We're getting into series, and we just jumped a little bit
I
ahead.
thought that was a review for the past 10
Given,
This kid's just not paying attention.
given a series.
I was paying attention. I was just...
Given a series. If all the terms added together are finite, then the limit as n goes infinity of an is 0. Now remember what we just said earlier? And I'm going to improve this. We still haven't talked about notation for series yet. So I'm probably going to write this again up here later with the better notation. But I really want this to make sense. The only way to have all the elements of something add together, the limit's got to be 0. But if the limit is 0, does that mean that I add them and I'll get a finite number? No.
No?
Nope.
Didn't we just...
I come see, here's the thing. Do you
Okay.
see? This is the logic.
You can't
Oh
flip them.
shit.
Right.
If then, right? If all the terms are finite when you add them together, then this is true. Does that mean if this is true, then that's true? No. No. So in order for a series to converge, and what does it mean when I say a series to converge? Can somebody remind me again what series means?
A series is an addition of an infinite amount of numbers converges to one
Yeah, so
single.
a series is adding up all the terms of some given sequence. You would think. That's all a series is. So given a sequence, the associated series is just adding up all the terms of that sequence. In order for it to have a chance to converge, the limit has to be 0. So did I just say if the limit is 0, it converges? Hell no, I didn't say that, right? I didn't say that at all. Are you with me at all? Are you loving this? This is our first major hurdle to get over. And it's exactly what I said earlier, in case you didn't hear me. If it's raining, I'm going to bring my umbrella. Then I bring my umbrella, correct? If it's raining, then I bring my umbrella. Does it work the other way? If I bring my umbrella, does that make it rain? Then it will rain. That doesn't make any damn sense.
Wish it did.
That would be neat, especially here.
We could use
right?
some rain.
Shit, yeah. But unfortunately, no matter if all of us bring our umbrella, Guys don't care. Yes.
We should ask
So that
Florida
means
we
if
can-
a sequence is divergent by oscillation, then that series it would converge at 0.
Say again. Sorry.
If a sequence is divergent by oscillation, meaning it goes up and down, up and
Sure.
down.
I'm with you.
That series, can that series
No.
be convergent?
No.
No.
Well, we'll see. So we got to get a little deeper into it. So there's a possibility there's one that doesn't, but you got to be careful. Positive and negative terms.
Yeah,
Yeah,
that's-
maybe. But even then, yes.
So, when you said like you can't do the opposite of the theory, so that's like saying if the limit did not approach 0.
Yes.
then-
If I can do you guys know about contrapositive and no? If P then Q, if not Q then not P. So if the limit as n goes to 0 of an is not 0, then the terms added will be divergent, for sure. Yeah.
Oh.
Like we said earlier, that's how we started this shit, right? One limit we just had was 3/4. So of course when I add them all up, that's gonna diverge. If I add 3/4 to itself forever, can that equal a number like 7? No, it's gonna go to infinity, right? So if the limit of some given sequence is not 0, then the sum of all the sequence elements will diverge. It will go to infinity. Of course it will, right? So if it's raining outside, then I bring my umbrella. If I don't bring my umbrella, it must not have been raining outside. So you can turn around. I don't know if you guys, we're not going to suddenly start learning logic. But if P, then Q is equivalent to if not P, if not Q, then not P. Those are equivalent. But you can't say if P then Q means if Q then P. No, you can't say that. Yes?
And this is only for series, not sequences.
Yes.
Okay.
So now we're talking about series. So
Okay.
sequences are so beautifully direct.
Okay, because I was like.
Sequences are so beautifully direct. How do I see if a sequence converges? Just look at its what?
Limit.
Limit.
Okay.
And then I'm done, right? Do you start to get a feel for why series will be harder? They just will be. We're going to develop many tests dependent on what the series looks like that will help us determine if it converges or diverges. Yes?
So if you can't flip around the logic for the if-then term, why can you do that when you're using it as a negative?
So it's called contrapositive. It's called, if I remember correctly. Because, so if it's raining, then I will bring my umbrella. You with me?
Yes.
If I didn't bring my umbrella, then it must not have been raining, correct?
Yeah.
Bam.
Okay.
Done.
That makes sense.
Okay. And again, we're not going to make this into a logic class, but there is certain levels of logic you really should know about. Right? And if any of you guys have done any computer science, you probably know a decent amount of logic with logic gates and all that kind of stuff. Right? If you haven't done any computer science, I'm sorry. What do you want? All right. But this is something that I think it's been easy to not worry about until now. Most theorems actually are known as if and only if theorems, right? So I call an object a square if and only if the sides are all parallel, two sides are parallel and they're the same length, right? And they make 90-degree angles out of us. It's hard. So there's things called if and only if, meaning they work both ways. So a lot of the theorems you've learned before now inherently work both ways, right? But if we have an if-then, it does not necessarily work the other way. Okay. In fact, well, let's see. We're working up towards that direction. So first thing I want to do, let's introduce some notation. And in fact, yeah, I like it. Let's do this. Let's see. Yeah, here. Let's look at a geometric series. So if I have this series here, 1/2, 1/4, 1/8, 1/16. So this is not a series, sorry, it's a sequence. If I have this sequence, right? Can somebody come up with a functional form for that? With a function of n definition for that.
1/2 to the n.
Yeah, like 1/2 to the n. Is that cool? Because if n is 1, I get 2, if n is 2, I get 4 on the bottom, 3, I get 8 on the bottom, so forth, right? Okay, I like it. If I want to develop the series based on this sequence, I'm going to use some notation that most of you guys should have seen by now. Let's see if everybody's seen this. So if I want to add up all the terms of an, see, that's way too many words for math people. All right? Words scare us. We like our symbols. Our symbols represent whole frickin' paragraphs. Right? And that's why, like, this symbol, how long did it take you to figure out what that symbol really meant? A while, yes? Right? And of course, did you guys all know it's just an S that's we elongated? Were you guys told that? It really is just an S, and they went, what if we do that? Oh, Nita, it means some, big S, good. You know, that's basically the drunk history of math, but it's basically the actual history of math. So there's a whole freaking section that explains this symbol, right? So we develop a symbol and we all know what it means, so we don't have to write a bunch of shit out for every problem. I just have to make a symbol.
What symbol is that supposed to be? Because that's how you draw your integrals.
That's
integral.
Okay, that is an integral? Okay,
Yes.
I'm just making sure because I like it.
Just a really big one. So, instead of saying all this, we use the more formal name for add is sum, and the capital Greek letter for S is sigma. Right? So you guys, that's right. You guys have all seen this because you all did Riemann sums.
Yeah.
Okay. I always kind of forget where the hell I am. Okay. So if I want to add up all the elements of this sequence, n equals 1 to infinity, right? Of 1/2 to the n.
Oh, I forgot you could even set bounds for a signal like that.
So that is a series. So do you see what I said earlier? A series is adding up all the elements of some given sequence. So you can see the sequence, there's the sequence, and this symbol means add them all up from 1 to infinity. So this is 1/2 plus 1/4 plus 1/8 plus 1/3, blah, 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 blah. For freaking ever, right? So the question is, does that come out to be a finite number? Huh? It does. I do know. So, what I want to do is this is the part that I didn't have time today. We're going to do this together. It's been a while. Let's see how this comes out. This is exciting. All right. We're going to do a proof for any geometric series. We're going to know what it adds up to be. We're going to prove what they will always add up to be. Now let me ask you this. Do you see, what would the R be in this? What's the R value for this?
2?
No. Let me write this a little bit better. In fact, you guys said this and then I didn't write it like that, kind of on purpose, but isn't that the same thing? Because what's 1 to the n? 1, right? Yeah, so what's the R value? 1/2. And that is less than 1, correct? Okay. I like it. So at least the limit of this series, right? What's the limit of this, limit of the sequence? What's the limit of this sequence? 1 over big freaking number goes to 0. So does that by itself mean the series converges?
Yes.
Nope.
No.
Nope. Does that by itself mean the series has a chance to converge?
Yes.
If that limit was not 0, I wouldn't have to do any freaking work here. If that limit was not 0, the series has no chance to converge. I know the answer is divergent. So if they say, check to see if these series converge, what's the first thing you do? Freaking look at the limit of the sequence it's built on. If that limit is not 0, Fantastic, I'm done. It's divergent. Leave me alone, right? I really want this to make sense. If I have this, and the limit is then goes to infinity of this is some number, I am eventually adding 7 to itself forever. That's what that means. That means this sequence will eventually become basically 7 forever. So if that limit is not 0, this series has no chance to converge. All right, I gotta calm down because I'm not getting enough oxygen in there. You'll pass out at the inside. Okay. All right, maybe. So this right here tells me, unfortunately, I have work to do. This series has a chance to converge because the limit is 0.
And only because the limit is 0.
Yes, if the limit was anything other than 0, we would be done. It would diverge. It would have no chance.
But for a sequence, that
Yes.
would mean it
Okay, I love it.
converges?
If does this sequence converge?
Yeah.
The sequence converged, doesn't it? Yes. Sequences converging, easy as shit. They just have to
Oh, okay, I
have
remember.
an actual finite limit, right?
Right.
Series converging, series are adding up an infinite number of numbers. That's going to be a little harder to tell.
Right.
Okay, I love it. Just keep that in mind. Sequences should be much more straightforward than series in almost everything we do with them. So if you're doing a series problem and it's a little bit quick, you should stop yourself and go, okay, let me make sure I'm looking at this right. Okay. The only way a series question could be really quick is if the limit of the sequence is not 0, then it's divergent. Next problem. All right, that's awesome. Does everybody understand that if that was anything other than 0, we're done? I know the series diverges. Okay, I like it. Remember the first day when I gave you this, did I give you this example? And I said, the elements are getting out of their own way fast enough.
Mm-hmm.
So isn't the limit of the elements 0? 1/10, 100th, 1,000th, isn't that going to 0? But it's going to 0 fast enough. So that when I add them all up, I just cut 0.1111. They're not like overlapping with numbers that are there already, maybe pushing it to infinity, right? I don't know if you guys get that. I really like that base example. This is a beautiful sequence that when I make the series out of it, the elements get out of their own way. Do you guys understand that? The first element is here. The second element has its place, doesn't it?
Mm-hmm.
Third element has its place. It gets out of its own way fast enough. Okay. A lot of weird shit happens in this chapter. Right? Okay. And if you can get the basic stuff down, just the basic idea of what we're talking about right now, everything else is going to be so much easier. Okay. All right. So, what I want to do is I want to do something for every geometric sequence where r is less than 1. All right? So, let's do some proofs for geometric series. Yeah, let's be more general. AR to the n. Right, because it could be, for example, what do you got, Jeff? It could be like 2, 6, 18. So this is like 2 times 3, or it could be like 6, 18, whatever. So this is like 2 times 3 to the n. You guys kind of with me? So you could have just an a there. Okay. Yes.
Can I, like, is it possible to pass the A out?
Yes, totally.
Okay.
Yes. Okay. Okay. So, here's something kind of interesting. Let me see. I want to, yeah, let's do this. What if I want to say this. Okay. So if I just start writing out what this is, isn't this a? Let me think. Give me a second. I think this is where they do that weird thing. So I'm going to do this weird thing. I'm going to bring this back to -1 here for a minute. That was what we did originally, right? Okay. So that would be more like if A is 2 and R is 3, wouldn't that be this sequence 2 times no 3s, 2 times 3, 2 times 3 squared, right? Okay, and that's still geometric because it's still multiplying. Okay. So let's write out the elements of the series. What's the first element that I would get? 2. No. Sorry,
One.
this is a specific example. Sorry.
Oh, A.
A, right? A times R to the 0. So I get A. Plus
AR.
AR. Plus
AR squared.
AR squared. Plus
AR
dot 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 dot. AR to the N. Right? Forever. Okay, maybe. And this would be what we call the sum, would be that. Okay. Stay with me. It's going to be a little weird. Now, and again, I don't know if you guys were here earlier when I'm like, I haven't done this in a while. Let's see how this works. So watch this. This is where things get a little bit interesting. What if I do, all right, real quick, I really want this to make sense. This is the symbol we use for like the sum of a series. This is the S is like L for limit, right? So S is the number I would get if I added them all up. Okay, I like it. Now this is where things get interesting. Remember, very often in mathematics we do some weird things like we multiply top and bottom by the same thing, or we add and subtract the same thing and stuff happens. You with me? So watch this. What do I get if I multiply S by R?
RA plus
AR.
AR squared.
Plus AR squared plus AR to the N plus AR to the N plus 1, right?
Didn't really make a difference.
So watch, just watch this. What is S minus SR? To take this stuff and subtract this stuff. Does everybody
-R.
see what happened here? All I did was take what I got for this sum and I multiplied all the pieces by R, correct? So A times R is AR. AR times R is AR squared, right? Now what happens when I subtract these two? Don't everything except A cancel, right? Everything, forever,
Wouldn't A cancel?
right? Why would A cancel?
You're subtracting.
Is there an A here? So why would that cancel?
Wait.
Here's S, right? Here's S, yes?
Uh-huh.
That's S. A plus AR. SR is AR plus AR squared. So if I subtract S minus SR, I get A plus AR minus AR plus AR squared minus AR squared. I am subtracting each of these. What if I subtract this? Yes?
Yeah.
Okay. So what's the only thing left alive? A. Now, what is it we really want to know? And you're all like, we want to know what the hell you're doing. What we really want to know is this. Isn't that the answer? Whatever this is, it's the answer, correct? So can't I solve for S? Can't I factor an S out? This is almost like when you do by parts and you have to add the same integral to itself. Right? So, there it is.
So what's the value it converge to?
So what is A in general? A is the first element of the series. And what is R? R is the thing I keep multiplying by. So for this series, for this, what's the first element of the series? What's the first element of the series? 1/2, yes? And what is r? What do I keep multiplying by? 1/2. So what is this sum equal to? The sum is equal to 1 over, I'm sorry, a over 1 minus r. So that would be 1/2 over 1 minus 1/2. Yeah, if you double the top and you double the bottom, you get 1. What the shit?
I still don't get how A minus AR is an R.
Yeah, same.
What?
Wait. A minus A, because you're
A
multiple. You can't.
minus
What?
AR. Are those like terms?
Right, but how are you getting A out of
No, 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 no,
that?
no.
No, they're not.
No, 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 no. It's A plus AR minus AR plus AR squared minus AR squared. I'm subtracting these from this. So doesn't AR minus AR cancel?
Oh, the whole thing infinitely.
Each term
Okay.
cancels except him. Yes.
Could you go over, how is that in AR form, the 1/2 times n? Wouldn't A be 1 and then R be 1/2?
No, A is the first element of the sequence, right? Right there. A is the first element of the sequence. And what was the first element of the sequence? Yeah.
That was crazy.
Yeah, I did hear that.
It was like somebody flew over there.
Yeah.
Interesting. All right. Are you ever going to have to do this yourself? No. Do I really hope somebody out there understands what just happened here? Yes. In fact, really quick, let me show you a concrete example of this happening. Let me show you a concrete example of this, right? Before I do that, though, can somebody real quick add up these elements for me real quick? Do it in a calculator, right? Oh, it's my hand, shit, I'm not gonna do it. So what do you get? 75 point, 0.825.8
It's,
8
do you wanna?
89 something?
Do you want what that equals?
What is it?
0.9375.
9375?
0.9375.
Yeah, 9375.
And then the value of R, wouldn't that be?
What do I keep multiplying by? I keep multiplying by 1/2, don't I?
Yeah.
Okay, R is what I keep multiplying by.
And then A.
A is the first element.
Oh, okay.
Do you guys see how just these terms is, what do you say, 9375?
Yeah.
Now add 1/32 to that. What does that be? 0.03, so that'll be like 0.96.
A lot of good progress.
0.96875.
So 0.9, so if I add that, it's 0.96875?
Yeah.
Do you guys understand? Doesn't that look like it is approaching 1? Do you remember doing the slopes, the secant line bullshit? You had to do the line, the tables. It sure looks like it's. That freaking looks like it's approaching 1. Yes, that's exactly what we just said. The sum is. So if you add 1/64.
0.98487.
See, Chloe's like, I know where this guy's going. 0.98. It's growing, but it's starting to slow down, isn't it? It does look like it's approaching 1, doesn't it? Yes? So if I add up all, and how many elements of this are there?
Infinite amount.
Infinite. But why does it add up to be 1? Because they get smaller fast enough. So they don't like go to infinity. They start adding to later and later decimal places. Maybe? When does this work? When does this work? Only
When the limit is approaching.
if I have a geometric sequence where R is less than 1.
Right.
What happens if R equals 1?
Then it's divergent.
What happens if R equals 1 right here?
Oh, it says A over 0.
It's infinite, right? It's A over 0, right? So R has to be less than 1. That's the only way this converges. Okay. So what's true about a geometric sequence? If R, the number it keeps multiplying by, if that is less than 1, the series converges. Yes?
Would this converge to 0 or to 1? 1.
Okay.
But the sequence
The
would
sequence
converge to 0.
converges to 0.
But the series
The series
Okay.
converges to 1, right? Series is what you get when you add up all the elements. Sequence just cares about what are the elements themselves going to. So they are going to 0 like they need to for the series to have a chance. Did you hear what everybody hear what she said? The sequence goes to 0. The series can't go to 0 because I'm adding a bunch of positive numbers forever, but they do just go to 1. 1. That's crazy. I think very few of you would have guessed the answer to this was 1. Right? And I'm not saying that, come on, you're better than that. No, I don't. That's the first time I looked at it. I'm like, I don't know what the hell that adds up to. How the shit would I know? Let's try another one. Okay. I'm gonna erase all. Let me kind of summarize some stuff here. I think I have, yes, it's on the handout. I'm gonna give you some summary of this. So geometric series look like this. If r is less than 1, then the sum of the elements equals s equals a over 1 minus r. And the letter s is almost exactly the same idea as the letter L for limit, right? It just means it's some number. We call the number s, right? Okay, maybe. Yes?
And what is A and R in this going to always be the same?
Yes, A is always the first element of the sequence, and R is always the number I'm multiplying by.
So they're always the same number? Like,
Yeah, what's the only way to give you a geometric series is if I keep multiplying by the same number. Arithmetic series, I keep adding or subtracting the same number. Geometric series, I keep multiplying or dividing by the same number.
okay.
That's the basic definition of those. So is this a geometric series? Not convergent, divergent, just is it geometric? Can't you rewrite this as, right? What would R be?
5/4.
R is 5/4. Is this convergent?
No.
Because R is
Greater
than 1. Oh, thank God. See, it's geometric series. Give me those, Jeff. Because all you got to do is write it as something to the nth power, and then you know what R is. And then you just got is R less than 1 or is R greater than 1? This diverges because R is greater than 1. R equals 5/4. So that rule doesn't even apply. That rule is built on R being less than 1.
But I think what she was asking is, are A and R literally always equal to each other?
No,
Yeah,
no, I appreciate that. Thank you. In fact, here's another one. All right, what about this?
Is that what you were asking?
Yeah.
Because
Yeah,
in
okay.
this case, what's the first element? 5/4. And what do I keep multiplying by? 5/4. But all I have to do is put a number here, right? Because what number, all right, so here, all I gotta do is this. 4 times 1/3 to the n. Right? Is that geometric?
Yes.
Yep. Yes, why?
Because 1/3 is G.
I keep multiplying by 1/3 to make the next element in the sequence that the series built off of. Let me say that again. I keep multiplying by 1/3 to get the next element of the sequence that the series is built from. Does the whole sentence make sense? I'm going to use that kind of language, yes.
If it wasn't to the nth power, would it be adding, it wouldn't be geometric?
If that wasn't there,
And it was n, just was like right next to the 1/3?
oh,
Then it would be this,
then that is
Not
definitely, obviously, what?
the other version.
As n gets bigger,
Divergent.
the elements just keep getting bigger and bigger, correct? In fact, what's the limit of this? Just the limit of that.
Infinity?
As n goes to infinity, it's infinity. So I know the series is divergent because the limit of the series, of the sequence is not 0, right? But the minute I do this, the limit of this is 0, because r is less than 1. 1/3 to the really big is really small. Yes?
So that means all, or not to say all, but most geometric series are to the n?
Yeah, every geometric series
Okay.
can be written in the form number times something to the nth power. Right? Yes?
What if you had a function that was 4/3n and you just pulled out the 4 and then you have 4 times 1 over. Oh wait, no, it's because the n, right?
Because
okay.
you have n 4s, not
Right,
just
right.
1 4. Yeah.
Right.
Okay, now real quick.
Okay.
Now be careful. What's A? 4/3. Good. What's the first term? What's A1? You have to let n equal 1, correct?
Four
It's
times
What do you get if n is
1/3.
1? 4 times 1/3. So the first element is 4/3,
R is
and r is
1/3.
1/3. So there you go. They don't have to be the same. I like it. I just did a couple of where they were the same. So can you figure out, is this convergent? Is the sum convergent?
Yes.
Why?
Because it's always
Because
getting
r
R is
less than
0.
less than 1.
You know what's funny is in my head I have the song less than 0 going for some reason. So anyway, anybody know that?
By who?
Okay. Can you tell me what the sum is? You know what A is and you know what R is, correct? And guess what you have to memorize? Little dude, right? So just plug shit in. Yes.
Does the 1 value ever change or is it consistently 1?
That is always 1. Yeah, and you could see from our proof, because it's when I took an S out, there was a 1 left. It's just always 1 no matter what's going on. Yeah.
Is it 2?
Let's see, 4/3 over 1 minus 1/3. If I multiply by 3, I get 2, right?
Let's go.
Nice. Is that cool?
Yeah, it's cool.
Yes?
It's kind of a what if scenario. It's like when A, say you have like 4/3n. Would A be 4?
Okay, wait. So, all right.
Oh, okay.
Oh, so you have, I see. So if you have sum 4/3 to the n.
Mm-hmm.
Okay. So I would do a little work here, just to really make sure you see what's what. 4 times 1/3 to the n, right? Which is 4 times 1/3 to the n,
Okay, so.
which is
The same thing.
the same thing.
Okay.
What happens if you pass out the 4? Would A be 1? Or,
If you put that 4 there,
yeah.
it would still, so what would happen is, all right, if I put that 4 there, A is 1/3, right? Right?
Yeah.
But I have to multiply what I get by 4.
So you would get 1/2 the new one.
So I would get the sum of this, but then what's the answer to the whole question? 4 times that. So I'd still get 2. Yeah.
So yeah, that means the sum.
So it's
would
like an
turn out-
integral.
Well,
Yeah, because
kinda, yeah.
what are integrals built on? Aren't they built on these?
Summations, yeah.
Aren't they built on these?
Yeah.
So whatever the shit I can do with integrals, as far as constants go, I can bring a constant inside and out. What's the only thing this thing looks at as not a constant?
1/3.
Anything that has a n is not a constant to a sum, remember? So if it doesn't have an n in it, it can come out. As long as it's a multiple, right? Bye-bye. Okay. All right, let's try another. Let me write this one a little bit differently. What about the sum of, what do you got, Jeff? 7, yeah, let's do 7 times 2 to the n minus 1 over 5 to the n.
Ooh. It does converge.
The question is, what does it add up to?
You can use the stuff we just did though on that one.
Can somebody see what's fundamentally wrong with this? Look at the powers. Do they agree?
No.
So there's no way to kind of like get my fraction, right?
Couldn't you though, take out the -1 by multiplying by, or?
Think
taking
about
out
it the other
2
way.
to the -1?
Do something to the bottom instead.
Okay.
How many 5s are on the bottom?
And
So if I factor the bottom, if I take a 5 out, how many 5s are left here? If I take a 5 out, how many 5s are left?
And minus
And-
1.
Oh, look at that shit. All right.
What? That's weird.
What's
It kind of-
5 times
You're
5 to
freaking me
the...
out.
Real quick, let that sink in. If that doesn't make sense, let me know.
Have you
You
played with
guys all see
factorials
that.
before?
I see it, but it's BS.
It reminds me of factorials.
It's BS?
It feels fake.
Feels-
Everything in math.
Everything math is fake.
We've been winging it for 3 years at this point. Come on, man.
It's gonna make me cry.
It's like my whole
You
life's
guys,
a lot.
again, when you're doing an integral of trig functions, for example, if the angles aren't the same, that's kind of like the first thing you attack, is you think about an identity to make the angles the same. Here, if the powers aren't the same, I can't consolidate that part.
And then you can collapse.
I've got to
that
make the
pit.
powers the same. So I appreciate what you were saying. You were attacking, but it's easier to just attack the other part. Just take one of the 5s out, right? Because now, what do you have? 7/5 times 2/5 to the.
And minus.
All right. So let's see. Let's see. What is A? When n is 1. 7/5.
Oh,
When n is 1.
You got me right there.
You
Okay.
got none of this. You got 7/5 times 1.
R is
Is everybody with me? And then what's R, of course?
2/5.
2/5.
Okay. What a shame.
So will that converge? Because
R is less than 2/5.
R is less
Or
than.
R is less than 1.
It's okay, I said 0. So, yeah.
So even though it's n-1, R is unaffected? Cause, yeah,
What do I keep multiplying by? 2/5.
okay.
Yeah, it almost does, as long as this power has n minus whatever plus whatever, that's what I keep multiplying by. When n is 1, I got no 2/5. When n is 2, I multiply by 2/5. When n is 3, I multiply by another 2/5. So R is just the repeated multiplication, right? In fact, R stands for ratio in this case. It's what one term divided by the next term, the first term is what I keep multiplying by.
So what if it's like a polynomial, that are still good?
What do you mean? Oh, if the
Polynomial
power,
n on the exponent?
if the power was polynomial,
Yeah.
do you want to do that right now?
Well, we're gonna do it eventually.
Yeah, yeah.
Okay.
Is that chapter 3?
No, it's, we'll do it, don't worry, it's not
Today?
here yet. Let's stick with this so far, right?
Uh-oh.
So can you, what's real quick, what's the S, what's the sum, what is this sum to be?
7/3.
In fact, real quick, before we do that,
Ooh.
tell me some more elements, so 7/5, what's the next element? And we know what we keep multiplying by. so-
14 over
Yeah,
25.
14 over 25.
Numbers are too big for
Right, what do I
number.
keep multiplying by?
28
Two.
over 125.
28 over
125.
125, right?
Uh,
So the series would be this, right? So I want to know,
6.
if I do this infinite sum, what do I get?
56
Doesn't it feel a little weird to be able to do an infinite sum as quickly as we are doing it? Yes, and I forgot I was going to show you this, right? I'll show it to you here. So what is this real quick? A over 1 minus R, 7/5 over 1 minus 2/5, multiply by 5. It's pretty cool when I do that.
Yeah.
Multiply top and bottom by 5, get rid of the interior fractions, and you get 7/3, right? Kind of freaky. So should eventually get to be 2.333333. Right, and let's see real quick, is that cool, everybody see that? If I add up all of the infinite terms of the sequence, I will get to 2.33. So let's see, 7/5 is 1.4.
I didn't know that.
14/25,
Uh,
0.56, so that's already 1.96, right? You see what I'm saying? And then 28 over 125, I don't freaking know.
0.232.
Thank you. Point what?
232.
232? So that's already 1.96 plus 0.232 would be 2.192, you think? I don't know. Does that sound right?
Sure.
So I'm already at 2.192 after the first 3 terms. So if I keep adding, these keep getting smaller and smaller. They keep adding less and less. And it's going to eventually come out to be 2.333, 7/3, right? 2 1/3. Maybe? Now I promised you guys a concrete, let me do a little side note. I want to see how many guys have ever seen what I'm about to do here. I think I did this before. Correct me if I'm wrong when I show it to you. So everybody got what they want from this freaky shit here? Okay. So real quick, this is a little side note, okay? Some of you guys have seen this, some of you guys maybe have never seen this. If I want to know what 0.111 repeating is as a fraction, right? Don't say it, but does anyone know what it is as a fraction? Okay, so don't say it. Does anyone not know what it is as a fraction? I love it. Some of you guys are like, you've heard of Schrodinger's cat. I'm that. I know it and I don't know it at the same time. Just don't open the box. Ah! You don't know Schrodinger's cat? Look at it.
Curiosity killed the cat.
So if you don't know what it is as a fraction, let's do algebra shit. Let's call it x. Because what do we do in algebra when we don't know something?
Call it
Call
X.
it x. So watch this. If I multiply by 10, doesn't that move the decimal over? Sort of like when I multiplied s by r, something very similar happened, just not as concrete. So can't I take the difference of these now? Do you see what's going to happen? What's the worst thing about this number? It's got an infinite number of ones. If I subtract these, I'll do this side. Here, what do I get if I subtract these? Don't all these ones just cancel? Don't I just get a 1? So then x is 1/9. And sure enough, if you do 1 divided by 9 in your calculator, you get 0.111.
That was
and you
pretty
all
cool.
already knew that shit. What's 2/9 then? 2. What's 3/9? 3. And of course, 3/9 reduces to
1/3.
And you all knew 1/3 was 0.333, right?
Crazy.
What? Maybe.
What's
Yes?
9
Blowing my mentality right now.
So I have a question on like some of the previous stuff we were doing. When you say that the limit of the series is like, or
No,
some-
no,
oh,
all right,
sorry,
no,
some of
stop.
the-
There's no limit of a series. It's
Yeah.
just the series.
Yeah.
The series already means add up all the terms. It already goes to infinity in its own way.
Yeah.
You with me? So there's a limit of a sequence, and then there's the series.
Okay.
And does it converge or diverge? Right?
When you say like the series equals 7/4, if you add up like an infinite amount of times.
Sure. Yeah.
Do you like mean it literally equals 7/4?
Yes,
or
yes,
it's, like,
yes.
negligibly
Literally.
equals 7/4?
Literally. So, what was the one we just had, real quick? I'm sorry. It was
7 times 2 to the power of n minus 1 over 5. Or,
and it
sorry.
became this eventually, right?
Yeah.
Okay. If I add up, and that's why I tried to write the concrete, what are the elements? 7/5, 14 25ths, 28 over 125. Is that cool, everybody? So if I actually do this addition forever, it will be whatever the answer was. What was it?
7/3.
7/3. Okay, so 2 was earlier. That's right. You will get 7/3. Literally, right? I really want to make sense. I want to make sure you guys got this. You guys with me? I mean, literally. If you add up every fraction, how many fractions are in this list?
I just don't know how that's possible.
Infinite number.
If you're adding an infinite amount of numbers, how
Totally.
do you get
Because it converges.
7/3?
What did
They
we
get out of each other's
But I
way.
get like getting really, really close.
Guys,
to
guys.
7/3. Yeah.
What did we just? Didn't we just here? Didn't we just subtract an infinite number of things? Like that? So I really, I don't want. Listen, guys. I showed you the proof of this formula earlier. And it was kind of based on a similar logic to this, right? Let me show it to you again. S was this here, right? A-R, blah, 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 right? Yes? That's what S was. That's again, let me stop saying literally. But that's forever, correct?
I like the
Forever. Forever. Just like this is freaking forever. And then I multiplied it by R. A times R is AR. AR times R is AR squared. And then I subtracted. So just like all the ones disappear, all of this shit disappears. Right?
Yeah.
So then I can solve for S, make an A. There it is, buddy. I give so few A's, I forgot to make, no. I rose myself for a second. Okay. I give out A's, I do, if you get it. Okay, maybe? So that's why I like that. That's a concrete example of this very abstract thing we're doing. This is an infinite sequence.
Mhm.
I can take that sequence and multiply every element by something, and then all of these cancel.
Okay.
I can actually do that with a concrete example, but
So if you put like that, every fraction we take with a series in decimal form, that means we'll have to get like an infinite amount of values, right?
do it again.
So like if we take the fraction and put that as like a real number,
The
like
fraction.
get over there. I mean like just a, I don't know what the word for it is, but like non-fract, like decimal form.
Mixed
Is
number.
it always going to be infinite or?
No. Do you remember we did one earlier? We got 1.
Yeah.
The answer was 1.
Okay.
And then I think the next one we did, the answer was 2.
Okay.
Wasn't that true? And then here we got 7 thirds. So the answer could be anything.
This is
In fact, the answer to some of these is going to be infinity, right? Because if this was 5 halves, the answer is infinity. Right? Okay, maybe. All right, so let me do this. Let me give you this handout. Because otherwise, I'm going to forget.
Is it a worksheet?
So.
Carmen, what's 7.3 on, or 11.3 on?
The interval test and then 11.4 is something. I knew what it was earlier.
Thanks.
11.1 is easy,
Oh,
right?
it's comparison test for 11.4.
Comparison test.
What is that?
There's a bunch of different tests to check.
Ricardo, they got one behind
There's
you
just a
already.
lot of rules.
There is a lot of. That's why I hated it in high school. There's so many rules.
I mean, I like
These
rules.
guys screwed us up.
I couldn't remember. Like the one that killed me every single time was like, oh, I have to check my old notes. It's like the alternating
No
or
worksheet.
something. Oh,
Oh,
sorry.
there is. There is a worksheet.
Let's see, senior year.
Of high school?
Yeah, I'm looking at my old notes.
I did not take notes for calc at all.
Well, my teacher gave them to us, and we had to turn in our homework this way. So.
Find your 5 different
Not like as an integral, because you can.
He's got 2, I think. Do you have 2? There's one for this man. Please give this man one.
Taylor polynomials. I love it.
All right. Let's take a look here. This wakes up eventually.
Where is my sequences and cities?
Maybe it's gonna wake up. There it is.
Sequences and
Oh, I
series.
have an eraser now.
Someday. There we go.
Someday.
Someday. Oh. Oh shit. Holy shit, it's as bright as it goes, alright. That's
Halloween is.
crap. Okay.
Are we going to be doing Lagrange error bound eventually?
Maybe. Yes. Eventually.
Because that looks like it sucks too.
Alright guys, take a look. So, can't really see it on this really crappy thing here. Let's see. Is it better if I do this? That's a no. Okay. I can't make it any brighter. Okay. Oh, that's better. Okay. So here is a series. Right. So these are the sequence elements, and the series just means you're adding up the sequence elements. Okay. So this is all stuff we've already talked about. It's an infinite series. We can talk about the nth partial sum. So this is getting a little more specific than we did earlier, where you kind of stop at the nth term. Now notice what I had to do. And by the way, this kind of reminds me of something that several people did on the last test. So I'm gonna just talk about it right now. Do you see how I changed the index? So the index is the variable I use for my sum. So if I want the nth partial sum, I want to stop at the nth term, I can't use the letter n to also be going from 1 to something, right? So see how I changed to k? The index changes to k? And who gives a shit? I can use any letter I want to there, right? Maybe. So now n on that part for the nth partial sum, that just means if I wanted the third partial sum, I would stop here, and I would just add only those. Are you guys semi with me? All right, so S3 would mean just add the first 3 elements. S without a subscript means add up all the elements. Okay, I like it. Yes?
Let's say you didn't want to add up the first 3, but you wanted to add up the 7th, 8th, and 9th. Would there be a way to write that, or would you have to be more specific with your words?
Oh, I see what you. So only you want. All right. So that would be like S9 minus S6. Does that make sense? Because that would leave you with 7, 8, 9 added together. Yeah. So
Okay.
there's ways you could do it, but there's no like general way to be just that. Okay. Blah 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 blah. So let's do a specific example of what I'm trying to say here. So look at this. So this is just adding one extra step on what we have to do in 11.1. 11.1, they would give you the series 1 over n, and they say, give me the first 5 sequence elements. This one says, find the first 5 partial sums. So if n equals 1, right? So S1 means add up all the elements through the first element. So can you guys help me? What's the list of elements, the first 5 elements of this sequence?
1/3, 1/4.
1,
1/2, 1/3,
1/4.
etc.
1/5. That's the first 5, right? Yeah. Okay. Pretend like you can see that. So S1 is just add them all up to all the way to the first element. So S1 is 1. S1 is kind of silly. S1 is add all the way to the first element. S2 says start at the first element, add all the way to the second element. So what would S2 be? 1.5, so 3 halves. Is that cool? What would S3 be?
Well over 6.
Yeah, 3 halves plus 1/3, right? 3 halves plus 1/3, so 9/6 plus 2/6.
11/6.
11/6. Is that cool?
Yeah.
So what would S4 be? It would be 11/6 plus 1/4.
So 44/24 plus.
Yeah, 44/24. Well, you can do 12.
12.
Right?
Oh,
so
yeah,
22
yeah, yeah.
12ths plus 3 12ths. 25 12ths. And what's S5? S5. Now you gotta do 25 12. Let me stop right now. Does everybody see? Guys, does everybody see where these are coming from? All I have to do, S1 is start at the first term and add all the way up to the first term. Okay, that's 1. So S1 is just always the first term. S2 says start at the first term, add all the way up to the second term. So that's 1 plus 1/2. And so forth, right? So now when I try to go S5, I already know the sum of the first 4 is 25 12ths. Now I just have to add 1/5 to that. So that'll be 125 60ths plus 12 60ths, right? Because the LCD of 5 and 12 is 60, yes? So 125 60ths plus 12 60ths is 137 60ths, is that right?
Yeah.
Crazy sums. Now real quick, this is 1. So if I look at the SNs, I get 1, I get 1.5, I get, what would that be, Jeff? 1.83?
Yeah.
I get 2.08.
Yeah.
Is that right?
Yeah. 2.083.
Look at me go. It's like I know numbers and shit. Well, I don't know, this one. That's gonna be, huh?
2.283.
2.283. Okay. So it looks like maybe, see how it goes up by 0.3 and then it goes up by 0.2 and then it goes up by 0.2. It looks like it's starting to maybe approach something, right? I don't know how much, let's see. Oh, let me get a little more room. So let's look at this. I got S1 is 1. S2, you should have done another sheet of paper, Chuck. 3 halves. S3 was 11/6, right? Yeah. S4 was 25 twelfths. And S5 was 137 over 60. Now here comes one of the hardest parts of this class. And sometimes we won't be able to find it because it's just too freaky of a pattern. But can we find a pattern here to write what Sn would be? Yes?
I know it isn't in the format right now, but we could do the bottom as n factorial.
Okay, good, because I want to talk about factorials. So, real quick. Has anyone ever seen this notation?
Yes.
And by the way, this does not mean n! So can somebody tell me what would 4, and that symbol is called a factorial.
2 and 2?
What? No, it's 1 times.
Yeah, it's 4 times 3 times 2
It's
times
just
1.
it's the number times all the
So you
previous
start at
numbers.
the number, you multiply all the way down to 1.
That's annoying.
You have a function in your calculator to do it. It's really pretty cool actually.
Okay.
Factorials.
Guys. Yes? So what's 4 factorial?
24.
Can you guys, how would you do this quickly? 6
Put it in your
factorial-
calculator.
Guys,
Sorry.
how would you do this? Everybody, stay with me now. 6 factorial over, let me write the whole problem down.
6 times.
Oh, please.
You
Well-
write all the multiples out?
So watch this. What is 6 factorial?
6 times 5 times 4.
6 times 5 times 4 times 3, is that?
Yeah.
So I can stop anywhere I want to, and the little exclamation mark means I
So it's
would
30.
keep going. But of course I'm going to stop there because the bottom, so 6 factorial divided by 4 factorial,
That's dope.
30. All right, you ready? All right. You ready?
Factorial is like the strongest function that we'll use.
Okay.
So if it's like a factorial over a power.
Guys,
Sorry.
do this one. Don't say anything. Look at me. I jumped from 6 and 4 to this shit. So let's see what you guys do. It's okay if you don't know. We just started talking about punctuation in mathematics here. So.
Okay, hold on.
Grammar's important.
I love it.
Distribute this.
I'm just waiting for somebody to say, what's the semicolon mean in mathematics?
Is there one?
Oh.
It's a big thing in coding, so I'm sure it's a math thing too.
No.
Well, coding. Yeah.
But that coding is like
all kinds of
complete.
punctuation.
Like I use semicolons all the time. Well, did I use
So guys,
semicolons?
guys,
You have to.
guys, hey, that means everybody.
It's been a while since I've done my coding.
Okay. Anytime I have a factorial, I start at the number that's given to me, and then I multiply by the next one down, right? So what's n plus 2 factorial? N plus 2 times, and of course, where am I going to stop?
N minus 1.
And then if I do that, that would mean keep going, right?
Mm.
So this would be n plus 2 times n plus 1 times n.
That's squared.
And then of course you could multiply it out if you want to. I don't see any reason to, so I'm not going to. Yes?
So at what point would you stop doing a factorial on?
Ah, that's a really good point. These are a little weird because they inherently tell you what the lowest n value could be, right? In fact, let's talk about something a little weird. And to get there, let's do this. Okay, so everybody cool with that? So your question is really, well, what the shit's n? I mean, when do I know if it was just n factorial, when would I stop? Well, you would stop when you get to 1, but you're like, how would I know when I get to 1? So it's dependent on the value of n, right? So can somebody tell me, let's see what you guys think. What's the lowest n could be for this expression to make any sense?
N minus n?
No, what's the lowest number n could be? And this expression still makes sense.
1.
1.
1.
But doesn't that make 0 factorial, right?
Yeah.
Alright, so let's figure out what 0 factorial is. What do you guys think 1 factorial is?
1.
Holy shit, okay. So let's do it. Let's build up to 0 factorial this way. You ready? Let me see if I can do this. Alright. So what is 3 factorial?
3 times 2
3
times
times 2
1.
times 1. What do I do to this to get to 2 factorial? What do I have to do to this to make it become 2 factorial? If I divide by 3, right? I get 2 factorial. Is that cool? That's amazing. So what do I do to 2 factorial to get to 1 factorial? Divide 2 factorial by 2. And then I get 1 factorial, correct? So how do I get to 0 factorial?
Divide by 1.
Divide 1 factorial by 1. 0 factorial is 1.
That's math. Well, it's like anything to the power of 0 is 1.
Yeah, is this
It's
similar?
sort of
rule?
like that.
Okay.
And in fact, you can basically prove that the same kind of way. So this is a really interesting question. There's more proofs. This is the most direct proof. But there are other proofs. If you go to YouTube and you search 0 factorial, what the shit is that, or whatever you want to put into the search engine, you'll get a bunch of videos, and you will see several that do this, and you will see some that do some other weird things. But this is how we figure out what 0 factorial is. It kind of makes some logical sense to kind of like go down, so I can get to 0 factorial, so I can see what it must be. What would 1/2 factorial be? Do you think that exists?
No, I'm sure it does.
Do you think it's something we'll worry about in this class?
Yes.
No.
Probably not.
No.
No. Does it exist? Yes.
Can you do it for
It
us?
does exist. What about negative fact? Yes, they do. Sorry. Yes, they do exist. They do exist.
Can you show it?
No, we're not. That's beyond us.
What math is that in?
That's a good question. Not real analysis. What would that be? Not numerical methods. Proof. I think I did it in a proof class, but I can't remember exactly.
Proof. There's a whole class.
It's been a little while.
How many math classes have you taken in your life?
There, I did a Euclidean and non-Euclidean geometry plus proof writing class.
What does
The
that?
first
What?
part of that
What is
sounds
that?
fun.
What did you just say?
Euclidean geometry is where triangle angles add up to 180. Non-Euclidean geometry is where angles and triangles add up to more or less than 180.
Is that possible? Wait.
It is.
Wait, I didn't know that was.
It's like surreal. It's
Real
where a
quick,
lot
guys,
of shapes and
guys,
surrealism.
guys, everybody. Since I brought it up, on the surface of a balloon, right? If you draw a triangle, it'll actually be not a straight line. If the space you're working with itself is curved,
Okay.
then triangles will actually add up to be more. And if it's concave versus convex, it'll actually add up to be more than 180 or less than 180. So our Euclidean geometry is based on rectangles and it's got the XYZ coordinate system, right? Are you guys
Got
semi
it.
with me?
Yeah.
Are we going to suddenly start talking? No, that's the most I'm going to talk. I'm going to stop right now.
That helped. I was just going crazy
No,
because
it's really
I thought
cool. It's really
I thought
cool.
my whole life just got turned
I don't
upside
want to
down.
teach much. But basically, where did we end up with this? Oh yeah, that's right. So is this, what's 2 factorial?
2.
2. What's 3 factorial?
6.
6.
What?
But careful, what's 4 factorial? 24, right? Well, let's see. So if this is 1 over 1, this is 3 over 2, 11 over 6. So if I made this 50 over 24, right? This could be the answer. No! I don't know if this is the answer yet. No way! But again, that's the sucky part about fractions, is the form of the fraction you might get at first might be reduced from what it needs to be so I can see the pattern. Are you guys kind of with me?
Yeah.
A little bit. So that's going to suck on some of these problems. Going to get fractions. And if you build them up, there will be a pattern that you can see. But if you don't see how to build them up, you're not going to see the pattern. So let's see if this might be the pattern. The top looks really funky, right? 1, 3, 11, 50, I don't know. So this would be
Times 2.
1, 2, 3, 4, so this would be 5 factorial. What is 5 factorial?
120.
120, so I have to double this. What's that going to be? 274?
Yeah.
So the bottom looks like it's n factorial. The top is going to be an issue though, yes?
Mm-hmm.
So this is 1, 3, 11, 50, 274. Oh my God. Right? So this might be one. Well, I don't want to, we're almost out of time, but it's obviously not just adding by something. It's obviously not just multiplying by something, correct? Something it could be would be like 2 minus 1 is 1, 4 minus 1 is 3, 12 minus 1 is 11. Maybe it's some kind of, it could be something minus 1, right? That could be it, but then 50 sort of doesn't follow. Are you with me? But what I want to start getting you guys to look at is, how do I even start to determine what the end form of something like Sn or An is? I have to be able to see a pattern. And now that you know factorials are a thing, so the way we got this, it looks like the bottom could be n factorial. Because for 1, it's 1 factorial. For 2, it's 2 factorial. For 3, it's 3 factorial. We built this up, so that's 4 factorial. Now I've got to think about what the hell is the pattern in the numerator, right? That looks a little bit more involved. Yes?
Mm-hmm.
Okay. All right. So we'll have to come back to that one. We need some more practice with these things. Let me point out a couple. We're going to do one more of these. I want to point out something. Here's the whole thing about geometric series, right? So I wrote it like this. I can't remember the book writes it like this or not. So here's that whole idea. Right, so these should be relatively easy now. Even this one, remember I got you ready for these, right? And then this one, now look. This is what we were talking about earlier. If the series converges, then the limit is 0, right? If the series converges, then the limit of the sequence itself must be 0. If the limit is not 0, then the series diverges. So what if the limit is 0? Does that tell you anything automatically? No, it can converge or diverge. If the limit is 0 of the sequence, could the series converge? Yes. If the limit is not 0, could the series converge? No. Good. So just seeing that the limit of the sequence is 0 is not enough to stop. You go, oh, it's 0, shit, right? If it's not 0, that's awesome because you're done. The series diverges if it's not 0. So if it is 0, you're like, oh, I got work to do. Don't go, it's 0, so it converges. No, shit, that means you got work to do, right? Maybe? Maybe. And then I try to capture the idea, again here, for a series to have a chance to converge, the limit must be 0. But if the limit is 0, that does not necessarily mean it converges. I'm going to keep saying that until you all go a little crazy. Real quick, let's do one more real quick. Just get the series, the partial sums. What's S? Well, actually, just tell me the sequence elements. And when n is 1, what do you get? 1/2. N is 2?
7, 6.
Who, what?
What? 2/3.
2/3.
3/4.
3/4.
4/5.
4/5.
5/6.
5/6. Okay. So what's S1? S1,
1/2.
just 1/2. S1 just means add from the first all the way to the first. Okay, it's the first. It's 1/2. S2, now you add the first and the second. Oh, I see. Then you get 7/6. Mr. Way ahead of us. Gotcha. So 1/2 plus 2/3 is 7/6. Is that cool? The old LCD business, right? So if fractions give you nightmares, just be prepared. You're gonna have a lot of nightmares.
13/6.
Yeah, if you add 7/6 to 3/4, what do you get? 14 plus 9.
Because it's 26.
What did you get? 14 plus 9? No. Yeah, 14 plus 9, 23 twelfths.
23
23
twelfths.
26 with the whole.
Yeah, 7 6 plus 3 fourths, right? Yes? That'll be S3, yes?
No.
S3 just means add the first 3 numbers. And isn't S2 the sum of the first 2 numbers?
What's not?
Alright guys, if I know S2, how do I get S3? I add the third number to S2, that's all I gotta do, right? So what's S4? I'll take 23 twelfths and I'll add 4 fifths to it.
63 60ths.
63 60ths?
163.
163 60ths, that sounds probably true. I don't know.
213 60ths?
Let's see, so you'll get 115, and
Oh,
here
no.
you'll get 48, right? Yeah, so it is 163, thank you. And then S5,
213 60.
7120s, really? Alright.
The calculator says.
I like it. Anyway, so those are the partial sums. So I think what we'll focus on next time is we'll sort of finish the sheet out. We'll start to try to develop formulas for Sn. It's going to take a little more getting used to. We just learned about factorial, and they're going to show up everywhere. Factorials will be everywhere very soon.
In my dreams.
That's enough.
In my nightmares.
They will show up in your dreams, yes.
So Carmen, I was trying to tell you what I hated earlier, and it was just everything. I hated limit comparison test. I liked the ratio test.
You wrote everything.
Alternating series test. We did